Hello, in this particular lecture, we're going to discuss first order, first degree differential equations. And mostly we are going to focus in this particular course uh, mostly on solving these differential equations. Okay, and why this is the case? Because mostly in examination, you'll find that solutions of differential equations are asked and mostly qualitative part is asked. Okay, so by qualitative part, I mean that mostly the questions that would come in examination or otherwise also even in your physics side, if you just happen to see, mostly the questions would be on the qualitative aspect of the solutions. Okay, so today we are going to discuss first order, first degree differential equations. So the title of the topic is first order, first degree differential equations. Okay, so first order, first degree differential equations. And mostly our approach, as I mentioned, would be more on solving these problems up. Okay, and mostly my idea would be to put you in focus that how the questions are being asked in the examinations or what one needs to understand. So for example, if you're preparing for some examination, let's say whatever like NET, GATE, TEF or whatever, you would find that in all of these examinations, questions do not like the concern of the examiner is not about how the differential equation is to be solved. The concern of the examiner is how well you can interpret the solution part. So I'll stick more on the question part here, and I'll mostly teach you this keeping in mind of the examination also, and keeping in mind to develop your calculus part. Okay, so this is what is my uh, objective with this particular lecture. So I hope this is something that you already know. So uh, so consider a first order, first degree differential equation. First order, first degree. Are you getting my point? Means first order. I hope this is something that you know. That is, I'm talking of order one differential equation. That is whose highest order derivative is one, and the degree over it, or degree on the highest order derivative is single. So overall, this is a first order, first degree differential equation, and so we can also say that this is a linear differential equation. So linear differential equation of order one. So we are discussing linear differential equations of order one. Okay. Now, if this is the case, if dy by dx plus py is equal to q, this is a differential equation where p and q are functions of x, or constants. So one of the ways to solve this differential equation, is to find an integrating factor. Okay, is to find an integrating factor. So what one needs to see that how can I make this particular differential equation in an exact form? An exact form means in an integrable form. So one sees that if I just multiply this entire side by e to the power integral p dx, so I'll write multiply both sides of the Bauer differential equation, by this kind of factor. This I will call as an integrating factor to this particular differential equation. And I can see that this particular e to the power integral p dx, if I multiply on both sides, what I'll get? I'll get dy by dx plus py, and I will write q e to the power integral p dx. Is that clear? I hope it is clear. And if you solve this up, so if I just see that what this is, if you see that if I write it as d by dx of y e to the power integral p dx on the left is equals to q e to the power integral p dx. So if I want to solve this differential equation, I want to find this y, isn't it? This is what is my objective. Isn't it? So what I have done, I have found this kind of integrating factor. Just give me a minute. Okay, so there are some kind of trivial disturbances going here and there all every time. So there was a cat around. Have to Okay, so fine. So are you getting my point? So what I'll do, I'll multiply both of the ends by this kind of integrate, this kind of factor, which I'm right now saying as integrating factor, and this is e power integral p dx. If I multiply on both of the sides, that is on the left and the right, uh, in very compact sense, to the left, I can write d by dx of y e power integral p dx. Let's see how. So if you just use this kind of thing, that if I try to differentiate e power integral p dx, what it will come out? See this, because this is exponential, this will revert itself. And then what is the derivative of integral p dx? It will be p. So this is like p e power. This is what it would be. So if you just expand this term, I'm expanding this particular term here. यहाँ पे देखो इसको, I'm expanding this particular term here. So if I expand this, what I'll get? First, differentiate this. Don't differentiate e power p dx. So you'll get dy by dx plus, then you place y as it is, and then differentiate this. So you'll get e power integral p dx, and then you will get p because of the derivative of integral p dx. So in very compact sense, you can write this thing as e power integral p dx. If you take a common out, then there would be some py, and then there would be some dy by dx. So I hope you're convinced that this particular portion can be written in this particular sense. Is that clear or is that not clear? Just reply. Is that clear or is that not clear?
Clear, sir.
Okay. Now what I would do, I would integrate this stuff up. So therefore, integration e power p dx, then there is an integration dx, and there would be some constant, and this will be like y into e power p dx. So if you want to find what is your solution, y? The solution y can be written as e power integral minus p dx, then integration q e power integral p dx, again dx, and then there would be plus c e power minus integral p dx. So this is how you find the solution to a first order, first degree differential equation. Is that clear to you? Is that not clear? I mean, is that clear or is that not clear? Is that clear or not clear? Alpna, is that clear? Saloni, is that clear? Kriti, is that clear? Monica, Kriti. Okay, good. Chalo. Okay. Now let us try to solve a few questions that will give you an insight to it. So let us solve one differential. So most of the questions that right now I'm giving you are from mathematics. So if you achieve that level of questions, you'll be easily solving the physics questions also. So I'll do all those questions. So I'm asking one of the questions that has been asked in GATE examination, and this is in maths. So this was asked for mathematics students. Okay. So the question says that consider the differential equation given by x square minus x dy by dx is equals to 2x minus 1 y such that y of x naught is equal to y naught. Such that y of x naught is equal to y of... Okay. This differential equation or this IVP means initial value problem. What is initial value problem? You are given a differential equation and then you are given some initial conditions. This is what is known as your initial value problem. So this IVP has a unique solution. If x naught comma y naught equals option number A, which has been given as 2 comma 1. Option number B is given as 1 comma 1. Then option number C is given as 0 comma 0, and option number D is given as none of the above. Okay, so let us try to solve this differential equation. This is fairly easy differential equation. Let us solve it. So how to go about it? What I would do, instead of even having even if you want this way, so I'll solve this way. So like this will be like minus 2x minus 1 divided by x square minus x, y is equal to 0. Is that clear? So your p is what? It is equals to 2x minus 1 divided by x square minus x. So your integrating factor would be equals to e power integral p dx. And that would be like e power minus integral. Is that clear? So if you differentiate this up, this will be your 2x x square minus x if you take as t. So 1 upon t dt will be log t. So e power minus log of x square minus x. Is that clear or is that not clear? So this will be your integrating factor. Is that clear?
Yes, sir.
Okay, so you'll get, I think, 1 over x square minus x. Now you see, your q is 0 here. Your q is 0 here. So integration q would only give you constant there. So y into integrating factor, that is 1 upon x square minus x, would be some constant. Is that clear? Y into integrating factor, y into integrating factor is q into integrating factor plus c. Q is 0, so this will be like only constant would be here, right? Integration of 0 is a constant. Constant plus constant is again a constant. So overall, this will remain constant. So this would be it. So your solution, y as a function of x, happens to be k times x square minus x. Okay, is that clear? Now let us analyze one of the options. So what does it say? It says that if I take x naught comma y naught as 2 comma 1, 1 comma 1, 0 comma 1, which of the selection of these x naught comma y naught would yield me a unique solution? Okay, so what has been asked? It says, the question says that what is the selection of x naught comma y naught I should make? Like, what selection of x naught comma y naught I should make in order to obtain a unique solution? So let us take it point by point. So you will understand. That is why I chose this question up. So let us take the first option. Let us take the option number A. Let us say that my x naught comma y naught is equals to what? 2 comma 1. What does it imply? That if I place at x equal to 1, if I place at x equal to 1, I will get 2. This is what it means. What it means, sorry, if I place x equal to 2, I will get 1. Is that clear? If I place x equal to 2, I will get 1. Is that clear? Or is that not clear? अगर x naught comma y naught का मतलब 2 comma 1 है, इसका मतलब if I put in my solution x equal to 2, I should obtain 1. Is that clear or not?
Clear, sir.
Okay, so what I'll do, I'll take y2 is equal to 1. That implies what? Y2 equal to 1 means 1 here, and I'll get k here. I will get 2 ka square is 4. 4 minus 2 is, I think 4 minus 2 is 2. So I'll get k is equal to 1 upon 2. So if I get k equal to 1 upon 2, what does it imply? That if yx complete solution will be y by 1 by 2 x square minus x. Isn't it a unique solution? This is one solution. This is a unique solution indeed. Only single solution is there. 1 by 2 x square minus x. So yes, for the selection x naught comma y naught is equal to 2 comma 1, there would be a unique solution. Is that clear? Is that clear or not? Okay, now why did I choose this question? You'll be surprised to see that, oh, this is such an easy question. Why did he choose? Okay, now let us analyze option number B, which was certainly not to be analyzed, because if you've got this question answer, then it is all fine. But I'm just trying to make you understand that if I use this option B and C's, how things would have changed. So if I take this option, that is 1 comma 1, had I taken my x naught comma y naught as 1 comma 1, what does it mean? It means that at x equal to 1, your y would be 1. At x equal to 1, your y would be 1. That implies 1 is equals to k times 1 minus 1. That is 1 square minus 1 is. So this will give me 1 is equal to k into 0. Is there any such k in real number which when multiplied with 0 would give you 1? So there is no such k belongs to R such that k multiplied by 0 would give you 1. So if these are the cases, that is, even if you solve this differential equation, you've solved this differential equation, you've obtained this particular solution also. But if I say that this particular solution passes from 1 comma 1, you would say no, it will not pass through 1 comma 1. So had you been given this particular option 1 comma 1, your answer should have been no solution, because it is not satisfying your initial conditions. It is not satisfying your initial condition. Is that clear? Because there would be no such k which when multiplied with 0 would give you 1. So this option would yield you, if this remains the initial conditions, what you would say? You would say that we will not end up getting any solution, because what does it say? It says that initial value problem has a unique solution if x naught comma y naught equals to what? So if x naught comma y naught happens to be 1 comma 1, it implies that your solution would pass through 1 comma 1, and clearly you can see that solution cannot pass through 1 comma 1. 1 comma 1 समझ रहे हो? ये solution है क्या? ये trajectory तो है. What is this? X square minus x क्या है? This is this. If you take k as positive, क्या यहाँ पे 0 रखो, यहाँ पे 1 रखो. This is a quadratic equation. quadratic KL problem. This is what it will be. This is your solution, x square minus x, given your k is positive. Okay. Now, if it says that it will pass through 1, comma 1, so you'll say, no, it will never pass through 1, comma 1. Okay, you can clearly see that it will never pass through 1, comma 1, because had it been passed through 1, comma 1, then there would be some k belongs to real, such that k when multiplied with 0 would give you 1, which cannot be the case. Is that clear? Or is that not clear? Okay, now the last option, 0, comma 0. What is the problem with that particular thing? So if I take 0, comma 0, what does it imply? It implies that y at x equal to 0, y would be 0. That implies 0 would be equal to k times 0 square minus 0. How many real values would be there, which when multiplied with 0 would give you again 0? There would be infinitely many values. You take pi, you take e, you take 1, you take 2, you take 3, you take Sudeep, you take anyone. So what is this? 0 into anything is 0 only. So any real number will satisfy this condition. So the initial value problem satisfying the condition that the curve passes through 0, comma 0 would have infinitely many solutions. Is that clear? So this is what I have wanted to make you learn from this particular question. So what was asked in examination? Asked was which particular selection of x naught comma y naught would yield you a constant solution. The answer would be 2, comma 1. Is that clear or is that not clear?
Clear, sir.
Okay, so let us move to a difficult question, and you'll be able to understand these are the category of questions that you are usually asked. Okay, that you are usually asked. Okay, so this is where I wanted to make you quite proficient. Okay, so probably this is like second question. Again, net examination, mathematics. Physics also I'll give you, don't worry about it. But I just want to होता है ना कोई चीज जब difficult लगे तो सीधे बढ़ जाओ उससे. So let yx be a continuous solution of the initial value problem y dash plus 2y is equals to f of x and y0 is equal to 0, where f of x is given as 1 if x lies between 0 and 1, and if x is greater than 1, it is equal to 0, then what will be the value of y of 3 by 2? Option number A given in the question exam was sine hyperbolic 1 upon e cube. Option number B was cos hyperbolic 1 upon e cube. Option number C was given in the exam was sine hyperbolic upon e square. And option number D was given as cos hyperbolic 1 upon e square. Okay. So how to go about it? Kaise correct? So now you see that your function on the right hand side, which happens to be a qx, q, is a piecewise distributed function. It is a piecewise distributed function that is for all x lying between 0 and 1, it is given as 1, and for all x greater than 1, it is given as 0. Okay. Now this particular differential equation, one needs to keep a caution. So what I'll do, I hope everybody has followed the question. Is that clear? So how to go about it? So let us first find, I will simply write 2y is equal to f of x, and then f of x is there. You don't worry about it. Now, first find the integrating factors. Integrating factor to this particular differential equation would be e to the power 2x. Is that clear? You can see that this integrating factor would be e to the power 2x, isn't it? Now, this function f of x would be will have two different values depending upon x. So what I'll do, I'll simply take two cases. So case number 1 would be if your x lies between 0 and 1. So if your x lies between 0 and 1, your dy by dx plus 2y would be equals to what? It will be equals to what? It will be equals to 1. Okay. And this implies that integrating factor is e to the power 2x. So I'll write y into e to the power 2x integration e to the power 2x dx. Is that clear? So this is 1. So I'll simply write 1 into integrating factor, that is e to the power 2x. So what I will get? I will simply get y is equals to y into e to the power 2x is equal to e to the power 2x divided by 2 plus some constant k1, and I divide it. So what I'll get, y is equal to 1 over 2 plus k1 e की power minus 2x. Now, given in the question, the initial condition is y0 equal to 0. So I'll use the initial condition and find k1. So I'll use the initial condition y0 equal to 0 and find k1. So y0 equal to 0 would mean that your k1 is minus 1 by 2. That is something that you can clearly verify. Place y0, k e की power 0 is 1, k1 plus 1 by 2 is equal to 0. So k1 is equal to minus 1 by 2. Is that clear? Okay. So overall, the solution would now look like y is equals to 1 by 2 minus 1 upon 2 e की power minus 2x. Is that clear? This is how your solution would look like if your x lies between 0 and 1. Now let us take the case 2. If your x is greater than 1. So if your x is greater than 1, then what does function says? Function says that for all x greater than 1, your function would be 0. So what I would do, for all x greater than 1, if my function is 0, so I'll write dy by dx plus 2y is equal to 0. Is that clear? Now my c would be like k2 e की power minus 2x. Is that clear? Yes or no?
हाँ भैया.
Okay, now how to find k2? Should I use my initial conditions? That is y is equal to 0. Should I use it?
No, sir.
Why should I not? Should I use it? Why can I not use it? Because you can see that this is the solution only if x is greater than 1. So I cannot use y is equal to 0 here. Okay. So now what to do? Now you see that this is a first order differential equation, isn't it? It is a first order linear differential equation. This is a linear differential equation. Linear differential equation of order 1. So this is a linear differential equation of order 1. So clearly y must be differentiable. And if y is differentiable, what does it imply? It implies y must be a continuous function. Okay, continuous function. And even if you don't write all these things, you see that in your question itself, it was given. Let yx be a continuous solution of the IVP. Okay, is that clear or not? So linear differential equation of order 1, y must be differentiable and y must be a continuous function. And if y is a continuous function, it must be continuous everywhere. At least it must be continuous on the entire interval of existence. Interval of existence of the solution, which is for all x greater than equal to 0. Because see, your function f of x is defined for all x lying between 0 and 1, then x greater than 1. So overall, your fx is defined for all x greater than equal to 0. So your IVP should have a solution, and that solution must be a continuous solution for entire interval of existence. Is this a continuous function? Yes. K2 e की power minus 2x is a continuous function. Exponential function is continuous everywhere. Is this a continuous function? Yes. Constant function is a continuous function. E की power minus 2x is a continuous function. Linear combination of two continuous function is a continuous function by algebra of continuous functions. So both of these functions are continuous functions. But where you may think that a problem may arise at the boundary where you're separating these, separating the definitions of the function f of x. So what I'll say that what I'll use, since this is continuous everywhere, so I'll say that limit x tends to 1 minus y of x should be equals to limit x tends to 1 plus y of x. That is, my function y of x must be continuous at x equal to 1. So I'm using continuity condition, continuity of y of x at x equal to 1. So I'm using the continuity of y of x at x equal to 1. Is that clear? So what does it imply? It implies 1 by 2 minus 1 by 2 e की power minus 2 1 minus h should be equals to k2 e की power minus 2 1 plus h. Is that clear or not clear? ध्यान से देखो. This is what it is. 1 plus h here. And here I've written 1 minus h. Is that clear or is that not clear?
Clear.
Okay, so this gives me 1 by 2 minus 1 by 2 e की power minus 2, and this here I will have k2 e की power minus 2. Is that clear? And this will yield me the value of k2. So k2 will be equals to what? E square by 2 minus 1 by 2. So k2 would be equals to what? E square minus 1 upon 2. Is that clear? I think this is fine. Now, if you use this value of k2, you'll find that your solution for all x greater than 1 happens to be e square minus 1 upon 2 e की power minus 2x. So this is a constant value, and this is how it is. And what was asked in the examination? In the examination it was asked, what is the value of y of 3 by 2? So what is the value of y of 3 by 2? So if you replace this, instead of this, you write y of 3 by 2. If you write y of 3 by 2 here, you will get e की power e square minus 1 upon 2, and then you will have e की power minus 3. So y of 3 by 2 would be like minus 2 to 3 by 2 would be this. So you just do certain things. I think this will be like e की power minus 1 minus e की power minus 3 divided by 2. And what I will take common out as, I hope I would take, what should I do? What is given in the question? If I multiply inside, I'll get e की power minus 3. And this is how this is what I get. एक बार ध्यान से देखते हैं क्वेश्चन किस फॉर्मेट में दे रखा है, प्लस को देखते हैं. E square. Okay, so what I'll do, I'll multiply divide by e square. So I'll multiply divide by e square. So y of 3 by 2 multiply divide by e square, so I'll get e minus e की power minus 1 divided by 2 e square. And what is this? This entire thing is nothing but sine hyperbolic 1 divided by e square. Is that clear? So answer should be sine hyperbolic 1 divided by e square. Is that clear or not? Is that clear or not? समझ में आया? ऊपर से चढ़ा गया सारा.
हाँ भैया.
Okay, so थोड़ा ध्यान से देखो, differential equation mostly you will find questions in this tune only, because what they want to ask is not that whether you know or do not know how to solve the differential equation. Obviously, you know till the level of MSc, at least you're quite aware of solving these things. They are more concerned with, can you go beyond it, and can you understand the qualitative part of the solutions? So let us do another one. So that like in differential equation, I'll use this approach only. And most of the physics part is something that we are going to do. Like, for example, solving a Schrodinger equation or solving particle in a box, or all those things we are going to see in physics side. But in mathematics side, we are going to just do more, like I'll be more problem oriented here. So this will serve your purpose as well, and mine also. So let us do another question that was asked in NET examination. And mind you, this is the question that I did wrong even while I was teaching. So don't make any kind of mistakes, silly mistakes in your examination. So the given was dx by dt was given as 2 times root over 1 minus x square. And initial conditions, that at x equal to 0, x is equal to 0 at t equal to 0. So they have given your independent variable as t, and your dependent variable here is given as x. And they're asking what can be the probable solution, what can be the solutions, the solution of this differential equation. So I'm giving you all these things like sine 2t, sine hyperbolic 2t. Option number B, x as a function of t was given as sine 2t, and then I'm given t, and this is like from t lying between 0 and pi by 4, t greater than equal to pi by 4, t lying between 0 and pi by 2, okay? And this question was asked in physics examination only. So it is not a mathematics question. Okay, look, this has been asked in physics. Solution of this IVP will be what? This is what is asked in the examination. So how to go about it? I hope it is clear. I mean, question to clear है? चलेगा सबके सब. I mean, question is clear. Or is that not clear?
Clear, sir.
Okay, so let us solve this differential equation. So given differential equation is dx by dt is equals to twice root over 1 minus of x squared. The first thing that comes in mind is the domain of this particular thing, isn't it? So let us first fix in our mind what would be domain. The domain would be only if 1 minus. Okay, so before it, in order to solve this differential equation, what I would do, I would use something called as variable separable. I hope you know this particular thing. What is variable separable? In this, what we do, if your function is like of dy by dx, and if your function on the right hand side can be expressed completely as a function of y and completely as a function of x, what do we prefer? We prefer placing the differential along with the function of y, like differential dy along with the function of y, and differential dx along with the function gx, and we try to integrate in order to find the solution. So this is these differential equations are called as your variable separable differential equations, isn't it? This is something that you know. Okay, and also understand because this is one kind of solution of the differential equation. With introduction of this kind of method, there would be some restriction of the domain. There would be some restriction of the domain. Why there would be some restriction of domain? Because see, if you divide this thing, like if you divide this 1 upon root over like dx upon root over 1 minus x square, one can clearly see that on the right hand side, it was, if it was there, you can place x equal to plus minus 1. You can place x equal to plus minus 1. Why? Because you can place x equal to plus minus 1 because at x equal to plus minus 1, this would be 0. But while you divide it, you cannot do so. So ये थोड़ा ध्यान रखना कि वेरिएबल सेपरेबल में as you do any differential equation using variable separable, the time you do it, at that very particular time, your domain gets restricted. So this is one thing that one needs to keep in mind. So what I'll do, I'll simply do this. Okay, and this would be like dt, and I'll integrate it both sides. Understand that this particular differential equation, like this particular thing, is only defined if your x lies between minus 1 and 1. Because see, root over 1 minus x square means what? It means that your 1 minus x square should be greater than 0. It implies your x square minus 1 should be less than 0, and it will be like minus 1 and 1. I cannot include 1 and minus 1. I cannot include 1 and minus 1. Even if I include 1 and minus 1, so if I include 1 here, or if I include minus 1 here, this will be 0. It implies your x must be a constant. Your x must be a constant, and that x constant value I can get from the continuity also. So don't worry about it. Even if I cannot have these values right now, that is, even if I cannot use these values, even if I cannot include my values at x equal to plus minus 1, don't worry about it. Right now, don't worry about it. Is that clear or is that not clear? Whatever I want to say, is that clear or is that not clear? मैं जो समझाने की कोशिश कर रहा हूँ, समझ में आ रहा है कि नहीं आ रहा है? कि if I divide it, then my domain would be restricted. अगर ये right hand side में होता, the domain would have remained x belongs to minus 1 comma 1 closed interval. 1 and minus 1 were admissible here. But if I divide it, now my 1 and minus 1 cannot be included in the solution. So you will be tempted to say, oh, this is not the complete solution. What I'm saying, since dx by dt is there, it implies your x must be a differential function. It implies your x must be a continuous function. So we'll see by continuity what is the value at 1 and minus 1. Don't worry about it. Is that clear or not? Jaldi bolo, is that clear or not?
Yes, sir. Yes, sir. Clear.
Okay. Otherwise, because there's lack of time today, so that is why I took only one class. Otherwise, this particular thing we'll finish it off by tomorrow itself. So 2t plus c, is that clear? Now, at t equal to 0, you know that your x is equal to 0, which implies your c must be 0. Place t equal to 0, sine inverse 0 is 0, 0 plus 0, c is equal to 0. So your solution will be sine inverse x would be equal to 2t, and that will give your x as a function of t is equal to sine 2t. Okay? Okay, is that clear? Now you can see that even at minus 1 and 1, your solutions can be found. even at -1 and 1, your solutions can be formed. Is that clear? So, like while you were doing it, you could not include these things. Now, since you know the structure, now you know that as x tends to -1, your 2t would be equals to sine inverse around -1. So this will be like minus pi by 2t. So your value of t would be minus pi by 4. Okay. So if your t tends to minus pi by 4, then your x tends to -1. And if your t tends to pi by 4, then your x tends to 1. Is that clear? Is that clear? Because sine to t is a continuous function. So it can be like this can be extended to 1 and -1 also. Is that clear or not? What I want to say that sine to t is a continuous function, okay? And if I want to define this entire solution on -1, 1, I will extend the definition, and I will say that at x equal to 1, x will be equal to 1 if t is equal to pi by 4, and x would be equal to -1 if t is equal to minus pi by 4. I'll extend those solutions, don't worry about it. So overall, understand this particular solution is only valid. This particular solution is only valid if your (2t) lies between minus pi by 2 and pi by 2. This comes from where, if you remember your standard 12th, you've seen that if your x lies between -1 and 1, your sine x must lie between minus pi by 2 to plus pi by 2. This is your principal range. This was your principal domain. So it implies that sine inverse x is equal to 2t implies 2t lies between minus pi by 2 to plus pi by 2. That implies this solution, which I have written over here, is only valid if my t lies between minus pi by 4 and plus pi by 4. Is that clear or not clear?
Yes, sir.
Okay.
Yes,
So
sir.
only if your t lies between minus pi by 4 to plus pi by 4, only then I can write this kind of solution. Otherwise, no. Okay. Now here you see the solutions are not in this fashion. Solutions are not in this fashion. Okay. So this gets clearly rejected. This gets clearly rejected because sine to t, like here it is given t equal to 0 to pi by 2. Forget about it. Forget about it. Now, only thing that remains to be seen whether A would be an answer or B would be an answer. A would be an answer or C would be an answer. Is that clear or not? Now, what has the examiner done? Examiner has continuously extended the solution. He has extended solution. He writes that the solution would be sine to t if t lies between 0 and pi by 4, open here, and here he has done close, no worries about it. And then he has written 1 here, and then here he has written sine hyperbolic to t. What do you think would be a solution? In both of them, what do you think would be a solution? The answer is this would be a solution. Why? Because this is a continuous function. Understand, this is a continuous function. See, at t tends to pi by 4, as t tends to pi by 4, sine to t would be tending to sine pi by 2, which is 1. However, this is not the case here. If t tends to pi by 4, sine to t would become 1, but it is not equal to sine hyperbolic pi by 2. Because if you place pi by 4 here, it would be sine hyperbolic pi by 2. So both of these will not form a continuous function. So this will get cancelled. This would be an answer. Because see, here it is a first order differential equation. Your x must be a differential function. If your x is a differential function, then it must be a continuous function. So which of the following forms a continuous function? This is a continuous function. You can see this. So this was the solution. So if t lies between minus pi by 4 to plus pi by 4, I can write xt as sine to t. So obviously I can write xt as sine to t for t lying between 0 to pi by 4. Because it is valid for minus pi by 4 to plus pi by 4. So obviously it is valid for 0 to pi by 4. What about t greater than pi by 4? So I will write only that function which will be continuous, So if I write what will be t tending to pi by 4 sine 2t. So t tending to pi by 4 sine 2t would be equal to sine into 2 into pi by 4, which is equals to sine pi by 2, which is equals to 1. So this will be 1 here. Is that clear? Is that clear or not? So this particular function is a continuous function which satisfies this differential equation, isn't it? Does it not satisfy this differential equation? Yes, it does. See, the above one obviously solves. Use x equal to 1 here. Use x equal to 1. X equal to 1, the derivative of 1 would be 0. X equal to 1, here it will be 0. So 0 equal to 0. So obviously x equal to 1 is a solution also, and it also satisfies the continuity conditions. Overall, option number C would be the correct answer. Is that clear or not? Is that clear or not? Okay.
Yes,
So
sir.
I hope I hope this is very थोड़ा तेज हो गया आज के दिन because I wanted to cover 2 lectures in one. Anyway, from tomorrow we'll have 2 lectures only. At 8:30 we'll keep the class. Today because of some issues I could not take at 8:30. So tomorrow be ready for this only, the differential equations. Okay. So we'll finish this thing using examples only, like using questions only. Okay.
Yes, sir.
Okay, bye bye.
Yes, sir. Thank you, sir.
Okay.